Hi everyone, Morgan here. Thanks for checking back in. So today we are going to be looking at your answer to the question on page number 4 to see how you did. Now, in a general statement, the rate law for this is going to equal k times a to some exponent. I'm just going to call it x, b to some exponent I'm going to call y, and c to some unknown exponent I'm going to call z. And hopefully this information will be able to tell me what those exponents are. So I want to choose two experiments where only one of the factors is going to change. So from number 1 to number 2, trial 1 to trial 2, only a changes. So I can compare 2 and 1. So what I get is 3.00 times 10 to the negative second is the rate, which equals k, times 0.20 to the x, 0.10 to the y, and 0.10 to the z, divided by 1.50 times 10 to the negative second equals k times 0.10 to the x times 0.10 to the y and times 0.10 to the z. The k's cancel, and in fact that term and that term will cancel also. So what I have is 2 equals 2 to the x, or x equals 1. Now, if I look at 2 to 3, only one factor changes. So we'll do 3 divided by 2. And this is going to be 12.0 times 10 to the minus 2 equals k times 0.20 to the first times 0.20 to the y times 0.10 to the z over, and number 2, that's going to be 3.00 times 10 to the negative 2 equals k times 0.20, sorry, bad handwriting, 0.20 to the first, 0.10 to the y, and 0.10 to the z. Those will cancel, the k's will cancel, even those will cancel. So this over this is 4 equals, that over that is 2 to the y, and this time y is equal to 2. So it's first order with respect to a, and it's second order with respect to b. Now I can compare, let's see, those stay, we'll compare 4 and 3 this time. Kind of seeing something already in the math here. All right, so the k's cancel. These cancel and these cancel. This over this is 1. 1 equals 2 raised, sorry, I forgot to put the z's in there, to the z. That means z has got to equal 0, because anything to the 0 is equal to 1. So what is the experimentally determined rate law? R equals k times a to the first times b to the second. And I don't need to include c because its exponent is a 0. Now when I solve this for k, it equals r over a times b to the second. So this says specifically to do it for experiment 2. So I'll take data from up here in experiment number 2. And the rate is 3.00 times 10 to the negative 2 molar per second over 0.20 molar times 0.10 molar quantity squared. And those molars cancel. And when I put that through my calculator, I got a 15 and 1 over molar squared second, or more commonly written as liters squared per mole squared seconds. Now finally, in experiment 4, my rate of formation of F is given. And I want to find the rate of disappearance for A. So I have 12.0 times 10 to the negative 2 molar per second in terms of F. Now, according to my balanced equation, there are 4 F's for 2 A's. I hope that's not your last report card. 4F for 2A. The F's cancel. And this is 6.0 times 10 to the negative 2 molar per second. And I'm not worried about positive and negative signs because we use the word disappearance and the word formation there. So that pretty much tells you which one's positive and which one is negative. Okay, hoping you got a perfect score on that page. Tune back next for page number 5.